Good morning, math wizards of Virtual Room 502. Welcome to Mr. Leggett, Eureka Math in the Morning. Mr. Leggett and Friends. Well, it didn't go quite like I planned, but it's close enough. How you doing, third grade? Having a good day, I hope. Good morning. Let's see what we're going to do today in Eureka Math. Zoom out a little bit here to see what's going on. And we're going to build non-unit fractions less than one whole. Excuse me, not less than one whole from unit fractions. All right, so you're thinking to yourself, well, what in the world does that mean? You're going to find out. First, we got to do our fluency practice, and it's find the whole. Oh, I'm very good at finding the holes. Oh, you are? Like where? Oh, I go out to the mines and I find where people have dug holes in the ground. Well, Princess Yvonne, thank you for chiming in, but we're not looking for holes, H-O-L-E, like where people dig a hole. We're looking for holes as the complete, W-H-O-L-E. Oh, you mean like the whole candy bar like yesterday? Yes, like the whole entire candy bar like yesterday. Or even the whole pizza like the other day? Yes, or even the whole pizza like the other day. Or even the brownie pan filled with warm, delicious brownies? Yes, exactly. That's the kind of whole we're looking for. W-H-O-L-E. I get it. Okay, good. Thank you for your assistance, Princess Yvonne. You're welcome. Well, I don't know if that was any real assistance or not, but let's go ahead and figure out what's what. You are not copycats here for the fluency practice. You are just listening and learning. You're staying on the video. Mr. Leggett works long and hard on these videos to do for third or fourth grade, depending what grade I'm with live. So I'd appreciate it if you would stick around, take it all in, absorb it, get those synapses going, like Ms. Easterly talked about many moons ago. Let's do a couple of number bonds. My name is Bond, number bond. And this number bond is a fraction. Think about what that fraction is called. And as I'm drawing this, think about what is going to go in these bonds. There's three of them, so probably 1/5 in each of them. Now let's draw another number bond. And this one is 2/5. And I wish it would have been the same size as that one, but that's okay. So you could probably think what might be going in these bonds here. Yeah, 1/5. See, 3/5 is made up of 1/5 plus 1/5 plus 1/5. You get 3/5. 2/5 over here is 1/5 plus 1/5. But now, what happens when we bring them all together? Bring them all together. Well, it'd be 1, 2, 3, 4, 5/5. And what do 5/5 equal? They equal one whole, just like Princess Yvonne was trying to confuse us all. Think about it. Let's draw, or I'll draw a tape diagram, not an ape diagram, but a tape diagram. And I'm going to break it into 5 parts. 1, 2, 3, 4, and 5. They should be equal. They're not. Think about it. 1/5, 1/5, and 1/5. What did that equal? That equals 3/5, right? This is math magic at its finest. What do I have over here? I have 2/5. And there we have 2/5. 3/5 plus 2/5 equals one whole. And if Mr. Leggett was thinking right, I would have done this with a little more room and put my one whole up there. So 5/5, one whole. Okay, that got a little confusing there. Let's try something else. Let's try another one before we move on to the application problem. Okay, we're going to start off with a number bond. My name is Bond, number bond. And this bond is, let's do 4 tenths. Okay. So what is going to go in these 4 number bonds? Think about it. If you said 1/10 plus 1/10, throw on another tenth and another tenth, what do we have? 1, 2, 3, 4 tenths. Let's go over here. And let's put in 3 tenths. Do you think this will equal 1 whole when we combine them together? We have 1/10 plus 1/10 plus 1/10. How many tenths do we have altogether now? Don't say it all together. It's an old joke. 1, 2, 3, 4, 5, 6, 7 tenths. Okay, let's prove this using an ape-tape diagram, not an ape diagram, but a tape diagram. And I'm going to break it up into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And for all intents and purposes, pretend they're all equal parts. And they equal 1 whole. So what do we have here? We have 4 tenths. 1, 2, 3, 4. I'm going to color in or shade in 4. 4 tenths. That's what it is. Then we add on 1, 2, 3, 3 tenths. And what do we wind up with? Well, 1, 2, 3, 4, 5, 6, 7 tenths. Isn't that exciting? I think it is. We're going to do one more. 5/8. So I'm going to go 1, 2, 3, 4, and 5. And what do you think is going to go in each of these little circles as part of the number bond? Or in this case, we'll call it the fraction bond. Well, it'd be 1/8, right? 1/8, 1/8, 1/8, 1/8, and 1/8. So you have 1, 2, 3, 4, 5 eighths. All right. Let's on this side put, let's do 3 eighths. And what's going to go in each of these little circles? 1/8, of course. 1/8, 1/8, and 1/8. So put those together, 1, 2, 3 eighths. Let's look at a tape diagram. Break it up into 8 pieces. 1, 2, 3, 4, 5, 6, 7. Terrible job, Mr. Leggett. And 8. And this represents 1 whole, Princess Yvonne. Not a hole that you dig, but the hole number 1. 1, 2, 3, 4, 5. Let's shade in 5. And 3 eighths. So 5 eighths plus 3 eighths. 1, 2, 3, 4, 5, 6, 7, 8 eighths. 1, 2, 3, 4, 5, 6, 7, 8 eighths are 1 whole. And that is how we're doing it. If we say 5 eighths and 3 eighths, they equal 8 eighths or 1 whole. I wish we could do that live. All right, take a little break right now. What I'd like you to do is go grab a snack, get a drink of water, tell mom and dad you love them, pet the dog, feed the cat, check up on little baby brother or baby sister, but don't be gone for too long because we don't have a lot of time. Maybe 2 minutes tops, and then come on back for the application problem.